This is a screencast for learning target 42, which is to find the important parts of graphing a rational function. You will see first a couple of the slides that you saw in class, some general reminders. In order to find the domain, which is helpful to know so you know where are values that don't work, you need to remember that you cannot divide by 0. So in order to find those values, you would set the denominator of the function equal to 0 and solve. Just remember those values do not work, so x can't equal those values. Mainly we will be looking for something called an asymptote, which is a guideline for the graph. This also kind of goes along with the idea of excluded values. Again, that goes along with your domain. For our vertical asymptotes, what we're worrying about is places where we would have those guidelines. And in order for that to happen, you would be looking at x minus a being a factor of the denominator only, not the numerator. Then you would set it equal to 0 and solve and find the vertical asymptote. So process, which I started for you below here, is you're going to begin, of course, by factoring that numerator and denominator. And again, you're going to set any factors of the denominator only equal to 0 and solve. For horizontal asymptotes, it gets a little trickier. First of all, in order to find them, you need to take a look at the degrees of the numerator and the denominator. If your degree of the numerator is less than the degree of the denominator, then y equals 0 is your equation for your horizontal asymptote. If the degrees are equal, then what you'll do is you will take the leading coefficients and set up an equation and have y equals a over b. If your degree on the top is greater than the degree of the bottom, then there is no horizontal asymptote there. That's because when you are able to simplify it, and it basically ends up being a hole at that particular place. Speaking of holes, if x minus b is a factorator of numerator and denominator, then you're going to have a hole. It says unless x equals b is a vertical asymptote, it doesn't really happen that way. Holes, the process is very similar to what you did for vertical asymptotes. You're still going to factor your numerator and denominator, and you set factors that are of both numerator and denominator equal to 0 and solve. So let's show you a couple of examples here. Notice that I'm asking you to identify all asymptotes and holes in your graph. The first thing I would do with this problem is I would rewrite it so that the numerator is in standard form, and that gives me x squared plus 3x minus 28 over x squared plus 12x plus 35. I do want to go ahead and factor this, and that's going to factor into x plus 7 times x minus 4 over x plus 7 times x plus 5. We're going to do our vertical asymptotes first. That is a factor of the denominator only, and that factor is x plus 5. Set it equal to 0, solve for x, and we get x is equal to negative 5 is my vertical asymptote. For horizontal asymptote, we compare our degrees. The degree of the top is 2. The degree of the bottom is also 2, so the degrees are equal. And because of that, we take the leading coefficients, which is the coefficient in front of the x squared terms, for top and bottom. So we have y equals 1 over 1, or in other words, just y equals 1. For our holes, we're looking for factor of both numerator and denominator, which is x plus 7. Whoops. And we solve that for x. We get x equals negative 7, and we say that there is a hole at x equals negative 7. So those are the important pieces of that particular graph. So let's look at one more example. This one is already partially factored for us. We do need to finish factoring it. So we have y equals x minus 3 quantity squared over y equals x minus 3 times x minus 2. Same questions. We'll start first with vertical asymptotes. In this case, the factor of the denominator only is x minus 2. Set it equal to 0 and solve. So I have a vertical asymptote at x equals negative 2. For horizontal asymptotes, if I multiply out the numerator, I will have x squared. So the degree of the top is 2. The degree of the bottom, already given to us, is also 2. So once again, my degrees are equal. So we have y is equal to, it would be 1x squared over 1x squared. Simplified is y equals 1. Wholes, looking for a factor of both numerator and denominator, and that would be x minus 3. Let me get back here. There we go. X minus 3 equal to 0. And when we solve for x, we get x. There is a whole at x equals 3. And that concludes this particular screencast.